before we get started, just a couple of notes. This webinar will be recorded. Everyone's going to have the recording sent to them sometime tomorrow. And we'll be taking questions at the end. If you have any questions, just put them in the question panel on the GoToWebinar. There's a GoToWebinar panel over here. And I think we're good to go. Nico will get us started.
Hi, everybody. Thanks for joining us today. We're going to talk about building applications in the healthcare environment. So a couple interesting things about building apps for healthcare. They have to be HIPAA compliant to protect patient information and clinical information that's in these applications. And typically they need to get that data from the electronic health record that's in the basement on premises at the health system. So we're going to touch on both of those things today, how to integrate as well as how to build and deploy applications in a scalable and secure way using Kinvey and Redox. So my name is Nico Skivaski. I'm the co-founder and president of Redox. We do the integration pieces. So we stand up APIs for applications in the healthcare world. And then, so I'll show you through that piece of it, and then I'll pass it over to Ivo from Kinvey, who will take us through how to actually build these applications using the Kinvey platform. So quick preview of what you're going to see here. So I'll talk through the mechanisms to integrate with any EHR. Typically, the health systems and providers you sell to will use one of many different types of EHRs, and there's different ways to hook into these guys. So I'll show you through that piece of it. And then what that implementation process looks like on the health system side. And then Ivo will walk us through the backend setup and then actually the deployment of an application using the APIs to pull out that clinical information. And then we'll hop into Q&A. So quick highlight here, Kinvey and Redox really partnered to help developers rapidly develop applications without having to do a lot of the back-end work of and DevOps involved in securing your infrastructure. So on the EHR side, what we do is stand up a normalized API to allow you to read, write, and query clinical data in the standardized way from any EHR out there. So currently, Redox is in production with around 36 different EHRs, and that number, grows every week or so. We're adding a new one these days as the network grows. So what I'm going to do is dive into a bit of a demo here to show off how that API works, how to set up an application with it, and some use case examples of how people have used it before. So this is our website, redoxengine.com. Anyone can visit it. Once you're here, if you create a developer account, you can sign up for an account. I'm going to log into my demo account here, but you'll be popped into an organization. So this is your startup or your application organization. From here, typically the first thing people like to do is check out the documentation. So this is developer.redoxengine.com. This documentation is open to the public, so you don't necessarily need to create an account for this. If you want to follow along, you can check it out as we're going through this. But the core concept here with Redox is that we have sources and destinations. So the source of data is what's creating the data, and then the destination is where it's going. So if you're sending data into the EHR, you'll create a source record within your organization, and if you're receiving data, you'll create a destination. So I'll show you how to set up both of those things. But typically, we like to figure out what data do we need, and that depends on the workflow you're trying to deploy within the healthcare organization. So let's say you're a scheduling app and you need to schedule appointments for patients. We have a scheduling data model down here that allows you to do that. So this not only allows you to query for available slots, and this is what that query looks like and what the response looks like here, as well as create new appointments. So if you were going to create a new appointment, you'd set up a source record and then post this data to us in this format. So this is our JSON data model. You'll notice as you look through it, there's things that exist in almost all of these data models, like the patient. So this is the patient object here, including their demographics and information that we know about the patient that will need to be included in these messages. A big part of what Redox does is normalize the data. So for instance here, date of birth, this date will always look the same. So from a programming perspective, you can always expect that the date will be in this format, regardless of how the EHR is receiving or sending the data. It's a big piece of what we do is maintaining the mapping from whatever the interface we're using at the EHR side into this standardized model. So we do this with every field in here. So you'll be able to depend on them as you're coding them into your application. Some other data models I want to show is clinical summary. This is where most of the clinical data for a patient would live, and it's available via a query. So you can query, this is the query parameters. You're really sending in the medical record number, so the patient's ID, and what it returns is a snapshot of pretty much everything in the medical record besides notes, but all of the other discrete data. So this is the example of that, and I'll show you some of that clinical information here. So if there's an advanced directive on file, we have allergies, there's past encounters, so anytime the patient's been in to see a provider or been hospitalized, including the diagnosis and reason for visit. And the list goes on. This is a pretty big set of data, including family history, social history, problem list, medication list. There's immunizations. So if you need clinical information, this is a great place to grab a snapshot of that. In the example that Ivo will show from the Kinvey side, they'll be using a lot of this clinical information to display it in the application for the demo. Another very commonly used model here is patient administration. So this is based off of the ADT concept, if you're familiar with interfaces in the healthcare world, but it's probably the most common interface, and it's really an interface that triggers based on anything that happens to a patient within the care setting, any movement the patient has. So if they're admitted, if they move between care settings, so that like transfers and then discharges, of course. Additionally, it triggers for any updates that are made to a patient's demographics. So if you need to make sure that you always have an up-to-date address or email address or phone number for the patient, you'd subscribe to a patient administration feed, and you get a patient update when there's information about a patient that has changed. So it includes all of their, the patient object in it, as well as any information that's changed based on the event type. So as you can see, there's a bunch of different data models here. These are specifications that, like I said, are to remain consistent between the various EHR systems. So whether you're hooking into Epic or into a Cerner or Allscripts or Meditech, and the list goes on. So we authored these in a way that we can be confident that they work across these different EHR settings. So for many of the applications that work with us, they'll plug into us once, subscribe to a patient administration feed, and we would split that out to the multiple health systems that they might be working with. And as you can see here, the destination specifies, where the data is going to or where it's coming from, depending on the directionality of the model. So once you've identified which data model you need, maybe you're doing orders and results, you can actually go into building your application. So that's what I'll show you back here within your organization dashboard. So let's say you're an application that needs to receive orders from the EHR. Maybe the provider's putting in a referral order or an order for a patient to use your application. We've actually done that in the past, where providers can order applications for patients. You would want to receive that data, so you'd create a destination record. So I have a few sample destination records already in here, but creating them is quite simple. Once you create it, within settings, you set up a callback URL. So this is an endpoint that Redox will post data to in real time as it comes out of the EHR. So if you want to receive that order, for instance, we'd post it to this URL. Your organization comes with a sample endpoint, so you can kind of see how it's set up here. I can show it to you. It's just a list of messages that have been sent through. So there are many developers on our platform now who use this endpoint for development purposes. So you'll see all sorts of random messages in here, but if you're testing out your application, you can check with us here and see if data is flowing across to better understand how to use the dev tools. You set a verification token to complete the security there, and then once that's set up and you've verified your endpoint and we ping it and get a response, you can go into development tools and actually test some of this out. So from here I can go in and pick which data model I want to send to this endpoint. So I'll send an order. It'll be a new order. And we have a small sample set of patients, so we'll use Barbara and a couple of providers. We'll use Dr. Granite here, and a couple sample orders that we might see. So this is a urinalysis order from the EHR. And this is what the data model looks like. And again, this is that normalized data model that it looked like this regardless of the EHR here. This is also editable. So if you wanted to add in your own patients, or you have a sample patient you want to paste in here, you can feel free to do that. So I'm going to change Barbara here to my name. We'll leave the white female in here. That's fine for testing. And then I'll go ahead and send this over to that endpoint. So what this just did was send it across to that endpoint that we set up in settings. And we can see that pop in here. So this is the order that we just sent across. If you want to pop in and examine the message, you can check it out. There's the information we changed with my name in it, and you can check out the headers as well. So the headers will specify, what's that verification token that we set up. So you can verify it's actually coming from the source that you expect it to, and the application name, and all of that. So that's on the destination side. If you're receiving data from the EHR, if you're sending data to the EHR, you'd create that source. So let's say that you received an order and now you need to send a result back in to the EHR. Again, we can check out the sample source that's in here. Within settings is where you'll grab the API key and create a source secret. So once you have that, you can go in and check out some of the dev tools. So we have some curl examples here. So if you're wanting to use curl to do this, you can put an order in, or actually we're doing results now. You can check out what that result message would look like. So this is that new result for Barbara, Pat, and your analysis. So this is a result message for that. So you can grab that there and use curl. We also have a Postman library, so if you want to download this and use Postman, you're welcome to pop in here and download the package, and you can do it all in Postman as well. Within your dashboard, you'll see that there's a message log and transmission logs, so you can see the different data that was sent through. So this is that order that we sent. Any errors that might occur, you'll be able to check out and troubleshoot here. So it looks like someone was sending to an unverified endpoint. Additionally, if you want to add in collaborators, other developers on your team that might want to check it out, you can add them into user management so you can collaborate on the same applications. And the last thing I wanted to show you within our dashboard is the subscriptions. So your organization will come with staging subscriptions already set up, so you can go in and start testing things out. And as we move and as we implement with the various health systems you may be working with, this table will be essentially a reference list of what are all the sources you're receiving data from and the destinations that they're going to, or all the sources you've created and where they're going. So various health systems and EHRs and the data model being sent across. So we have groups that we're working with that have dozens and dozens of these subscription records going to various EHRs with various data models in place. So that's kind of an overview of how to set up the API experience. Once you're ready to start working with your health system and actually bring this to a health system and say, okay, we're going to integrate with your EHR, that's when Redox likes to get involved and start working with you. So I'll quickly go through what that implementation process looks like, but the main idea is first we'll talk through the integration that you've set up and make sure that we're ready to bring that to the health system, and then we'll actually put together the implementation project plan for you, so you can bring that to the health system and they know that you have your ducks in a row and you know where this is going. We also adjust those implementation plans based on obviously the unique scope of your integration, but also the unique infrastructure that the health system has set up. So once we know which group you're working with, we'll do some digging and figure out which EHR they're using, what we can expect them to have implemented with that EHR based on the type of health system they are, and go to them with a plan that is quite tailored so their IT team is highly confident in our ability to move forward with an integration. The other things that we like to do is, you know, if Redox is already implemented at that health system, we can move a lot faster within this implementation process. Let me talk through that implementation now. So this process can, you know, if it's a new health system that we're bringing online, can take anywhere between 2 and 4 weeks. Depending on the scope of the project as well as how quickly the health system can work with us on getting through some of these steps here. But it starts off with establishing connectivity to the healthcare organization. So this is the work that Redox will, we have, you know, technical project managers that work through this project with you, and we'll work directly with the IT team to set up most of this and bring your team in as necessary. So we'll set up a connection to the health system. Typically that's a VPN that we'll maintain between the health system's data center and Redox. Once that's in place, we'll set up, we have some automated pinging mechanisms to make sure that it stays in place. And so we'll start testing those and make sure that the connectivity is solid. Next we move into configuration. So this is where we're actually receiving data from the health system and building the mapping tables into the Redox model. So we've gotten pretty fast at this. Because we've you know worked with so many different EHRs and different customizations of how those EHRs have been implemented that this process, you know, can take a couple days as we receive sample messages from the EHR and map them into our models. But as soon as that's ready, we go into testing, so we can start looking at, okay, did data mapping work for, you know, messages in the staging environment for the scenarios that we expect and scenarios that we wouldn't expect, right, the edge cases. So we look at that functional testing of is the data moving appropriately. Then we go into full workflow testing, that end-to-end testing, where now we're passing that data to your staging endpoint and vice versa, so we can actually work with the health system on testing the full integration workflow. And this is where the IT team has the biggest involvement at the health system, is validating that the messages are coming across and filing into the EHR appropriately, and messages that the EHR is creating are filing in your application. You know, we'll work with your team to make sure that they're filing there appropriately. It's towards the end of this process where we typically see applications kick off their training process with their end users. So regardless, you know, if you're working with doctors or nurses or anyone on the care team who might be using your application, or even patients, right? There's probably a time period where you're training somebody on how to use it or how to deploy it to the right party. And this is typically done with that testing or staging environment within the health system. During the go-live process, we typically start with a soft go-live where we move everything into production, and we watch production messages go across just to make sure that production is actually the same as what we had set up in staging. It's, you know, more often than ideal, we see abnormalities in a production environment, so we'll have to do, you know, a little bit of changes there. This is typically between a couple hours and a day or so in a soft go-live environment and in production. And then we go to go-live, which is end users are now starting to use the application. After this, Redox is really in maintenance mode. So we are working with the health system as they upgrade their EHR. They might change the interfaces. So we become part of their upgrade schedule to make sure that they notify us and therefore keep the interfaces that are set up working. The other things that we do is maintain the connections over time. So and monitor them. So if anything goes down, if that VPN goes down, you know, we're the ones who get paged and, you know, get up in the middle of the night to call the health system and figure out what's going on. if something has changed. If they changed a workflow in the EHR and it breaks something, we're the ones who resolve that issue. And of course, if your application's isn't responding appropriately as we're sending messages to it, we'll call up your team and figure out what's going on there. So we really see ourselves as that first line of support 24/7 for the interfaces that we're maintaining. Of course, a lot of the applications used in the healthcare environment are vital to patient care. So that's why we have the 24/7 support and uptime requirements for a clinical setting like that. So that's how we will actually implement with the new health system. But if a health system is already working with Redox, there's about 100 health systems across the country now who are deployed in some capacity in a production environment with Redox, and then another 30 or 40 that are in an implementing phase. If we're already working with one of the health systems that you're working with, there's tremendous efficiency gains to be had, and that's the whole point of what we're trying to build here with Redox, is this interoperable network of health systems and applications that are all connected through this API platform, as well as through the same data models that we're exchanging. What this allows is for health systems that are already plugged in and using the interfaces that you need to use, those are already mapped into Redox. We can actually skip that whole upfront setup process and move right into testing. And sometimes, that testing process, after we validate a quick workflow, we can move that into production very quickly. So we've had, at the fastest, we've had applications go live within 48 hours. Day one, we start sending staging messages and go into testing right away. And if it looks good, we move into production day two. So that's the power and efficiency gains that joining a network like Redox can really offer. It's not just about getting data from your application into the health system and back again. For us, it's really about connecting another health system and another application to this network that will become more and more efficient over time as it grows. This, for us, is really about systematically solving this interoperability problem in healthcare, not just prolonging it or making it a little bit better by adding on another point-to-point interface. So that's my overview of the integration side of this. Of course, you need to actually have that application to integrate, which is really where Kinvey can play a part here. So on the application development side, I'm going to pass it over to Ivo now to talk through how to actually get this deployed and build out the application piece of it, and then how to hook it up to Redox and use the APIs from the Kinvey platform.
Hey, thanks, Nico. So my name is Ivo Janssen. I'm a solution architect with Kinvey. That was a great demonstration on how Redox can simplify the access and the integration of EHRs and publish really a modern API. So what I'm going to cover in the next 30 minutes is how Kinvey can bring this EHR data to a mobile experience. So let's start with a really quick review of the architecture of our backend as a service. So from top to bottom, Kinvey enables rapid front-end development through a number of SDKs, whether it's a native Android or iOS, or a hybrid platform like Ionic, Angular, or Xamarin. So these SDKs accelerate front-end development with features like single line of code authentication, abstracted data access, real-time live data streaming, client-side offline caching. And the SDK interface then with the Kinvey backend that services these authentication and data flows to either our built-in HIPAA-compliant data stores, our built-in HIPAA-compliant file stores, or to external authentication and data services. We also give the developer the ability to orchestrate these requests through business logic in our own hosted path layer, use cloud caching, initiate these live streams, send push notifications, send emails, etc. So what I'll show you today is how a mobile application can find abstracted prescription data for a patient. And we'll show you how an application would get that all the way, ultimately getting this data from Redox's clinical summary object. So how we're going to do that first, we'll set up a Redox integration service in our service catalog, creating an abstraction for this data source, and we call that a collection in Kinvey. So the front-end developers then can work against this abstracted data model and build our application. Once both parties have completed their integration, we can link the two together by linking the front-end collection to this back-end service from the catalog. Okay, so let's dive a little deeper and let's go to our dev center. So let's talk about the developer experience, right? We're a self-service platform. We try to make it especially suitable for folks that might be a little bit new to mobile application development, web applications, wearable experiences. So the key to self-service really is great documentation, samples, and SDKs. Today, we support 12 different mobile development platforms with 12 SDKs. We're constantly updating this by supporting new platforms when they come out. And our documentation is presented in guides to really dig down in all the reference APIs, tutorials, and lots of sample code on GitHub. And we've gone to great lengths also to ensure that our SDKs and documentations look consistent across all these SDKs. Like, for instance, this is our Angular SDK. Let's look at what it would take to log in a user. Go into the user guide, Dev Center, go to login, and here you can see the single line of code that our SDK exposes to log in to a Kinvey with the username password. And now if you switch to a different SDK, for instance iOS, we see that now the same SDK is exposed in a very similar way in Swift. So this really gives you the peace of mind that all features are supported really on every SDK. And what we found is that Dev Center code snippets like these are really useful. We see people just basically cutting and pasting this type of code straight into a mobile app and use it. And for non-technical people, we even have integrated with rapid development tools like Ionic Creator, where you just have to type in some credentials and you're good to go. Okay, so let's log into our console here, the Kinvey console. So this is where developers start building out their backend. To log in with my demo account. And to create a new application, just click Add an App here. Let's do something, my patient app. Okay, so what is this creating? This is creating everything your app needs instantly available and provisioned for you, right? So there's no spinning up of VMs or databases or using third-party systems and plugins and stuff. With Kinvey, your backend and all the features I discussed earlier, the data store, the file store, push notifications, the pass layer, everything is instantly provisioned and available for you. And we, Kinvey, take care of the hosting and the scaling and the uptime for you. All right. So let's get going with Redux. My next goal is now to build what Nico showed us and build on top of that and create some backend integrations for the clinical summary model. So instead of this app, let's go to the applications I've already created for this demo. So this is the main dashboard for Kinvey developers. So here we see all these abstracted front-end objects that the mobile app can access, right? And it includes the sources, the data sources that backend that service these collections. So we have a HIPAA-compliant data store. So some of these collections, like health concerns or activities or feedback, are stored in our HIPAA-compliant database. And other collections are backed by third-party systems. So in this application, we have integrations with Salesforce for doctors, patients, appointments, integration with PocketDoc for insurance-related information like deductibles, and of course Redux for medical records. In this case, we're going to focus on prescriptions and immunizations. So let's do that. I'm going to walk you through setting up one of these services. Let's go to the service catalog on the top left here. Let's add a service. So we have a number of integrations available for you. We have no-code integrations to popular APIs like REST APIs, Salesforce, SAP, SharePoint, SQL Server. And then we have a number of low-code integration options available to basically any other system out there, including our reference Flex connector for Redux. So let's make sure to understand what low-code means in this context. So basically what it means is that I can create a small JavaScript microservice to run against our Flex SDK, our backend SDK. And then I will deploy this microservice into our Flex services runtime. That's our platform as a service layer that comes as part of Kinvey. So we have our own platform as a service. Earlier you saw Nico in his demo as an example show a test route into Heroku. In a production environment, this will be replaced by our HIPAA-compliant system. So the Flex SDK really takes care of all the heavy lifting, like creating listener APIs, JSON parsing, etc. You can focus on just the transformation logic for your data source. I can actually show you this. Here we have some backend code. I'm using our backend SDK, the Kinvey Flex SDK, and this really focuses on mapping the fields that we get from the API from Redux into the Kinvey collections, right? But since this is a reference connector, we actually went a step further, and all you really have to do is edit this configuration file. We already set up all the logic to do these mappings. It's all done. All you have to do really is configure the mappings, right? So here you create the mappings between the various data models and the Kinvey collections. We call them service objects in this context. So, for instance, I have a service object called patient. If I query, if the application, the mobile application will query on it, we will go to the patient search model query. If I would get a patient by ID, then I will go to the clinical summary model. If I update a service object, I would actually send an arrival message on the ADT feed in Redux. And then Redux, of course, takes care of bringing that appropriately to all the EHRs. Right. So now I've completed my development, my configuration. I can use standard CI/CD tools to get this deployed into the Kinvey runtime. So how does this work? First, I write my code. I do it in my favorite editor. Once I'm done, just open up a terminal and probably do some kind of git commit to send this to GitHub, just typical CI/CD flow. So in a real CI/CD integration, this commit will most likely create some kind of trigger in a tool like Travis CI or Jenkins for automated test and deployment. But I'm not going to do that in this demo. I'm just going to deploy to Kinvey from my local command line. So I can use the Kinvey CLI to deploy this code into Kinvey. Lots of logging in. HIPAA compliance makes me not able to remember my password. Okay, so it's deployed, or it's being deployed. The job is submitting. So while this is deploying under the hood, Kinvey is provisioning all the necessary infrastructure to host and run this microservice. So you, as a developer, don't have to worry about scaling, maintenance, uptime. We take all that care of that for you in our PaaS layer, right? So again, this takes care of that integration that Nico showed you earlier from Heroku. This takes a second to go. I can actually switch to the one that I already predefined. So now we're going back to our application here. Now what I can do is basically build a new collection interfacing with this new backend service that I created. My clinical summary, I create a new collection, and here I can choose what data service should back this collection. I can go to Redux. Here we have a list of the service objects that are queried dynamically from my deployed microservice that is now running inside Kinvey. Use patient and hit confirm. Right. So at this point, my clinical summary collection is mapped against the Redux reference connector and going according to our mappings to the Redux backend. Right. Now, EHRs are not really fast. They're not built for speed, and certainly not mobile speed. People on a phone, they got anxious if a request even takes more than 500 milliseconds, and in a live EHR lookup can definitely be longer than that. So what I can do is I can turn on cloud caching. This is really powerful, right? You just turn it on here as an example. So what this does, with turning on caching, is I'm making the access of this data for the app highly performant, even if the underlying EHR is slow, right? So we're creating a side cache, side lookup cache for this collection, caching every data packet being retrieved inside our caching layer inside Kinvey. I can demonstrate this for you in our testing console. So remember, get by ID would trigger a clinical summary on the object. So I know this is Barbara's ID. Hit send here, and here you go. Now in Kinvey, we have retrieved the full clinical summary model that that as it pertains to Barbara Bixby. Where's Barbara? There she is. Right. Okay. Well, let's go one step further by adding some additional orchestration to this model. Right. So I don't want the front-end developer to have to worry about Redox IDs or EHR IDs or even MRMs. So we can utilize business logic to further abstract the interface. Right. Let's go to our users. Here in our user table, I have the same 4 users that the Redox demo had. So here's Barbara. You can see our MRM. So what I'm now going to do is write some business logic to look up the MRM for Barbara when she's logged in, and then automatically do the request on her behalf with her MRM. We can do that for prescriptions, for instance. If I go to prescriptions, for every request into the prescription, fetch. First, look up the user. Second, look up its MRM. And then third, do a new request into Kinvey, but now against the clinical summary object with the MRM attached to it. Again, let's take a look on how that works. What I can do in my testing console is I can impersonate users that are logged into the application. So here I'm going to log in as Barbara. Okay, password from Barbara. There we go. And then if I simply get prescriptions without anything else, without knowing anything about MRMs, I just logged in as her, I'm getting my prescriptions. There you go. Here's her prescriptions. And what I also did in the pre-hook is basically define the data model to not output the full clinical summary model, but just the data that the mobile application needs. Right? Just these 5 fields: name, dose, and frequency. Right? So at this point, I got all my backend services set up, ready for my front-end developers to use. Right? All backend services are abstracted away through these collections that have a well-defined data model. So for prescriptions, I just have these 5 fields, no MRNs, no HL7, so nothing. Okay, so I'm going to switch my head now and switch to being a front-end developer. Right? So my patient experience is going to build out an application in Swift in native iOS. For that, what I need is my application key, my application secret, so the application knows how to log in to Kinvey and how to get its information. So let's switch to Xcode here. First step is to simply use the Kinvey SDK, drop it in as a CocoaPod, initialize the Kinvey client. Here's the code. This code comes literally just exactly copy and pasted from the dev center, right? That, again, a lot of this code is simply copy and pasting. Login. This is the login code that we saw earlier from the dev center as well, right? Username, password that we get from the view. And login. So let's look a little bit at data now. Back to the dev center. Go to the data store guide. What we see here is exactly how to write Kinvey models in Xcode. And also in terms of controllers on how to deal with these data stores to find by query or find by ID certain information. Okay, let's go back to Xcode. And in my prescription model, you see exactly that I pretty much copy and pasted that code from the dev center and then adapted it for that data model that we agreed on with the backend developer, right? Name, dose, and frequency. So this is my model. And then in terms of controllers, you can see on how we deal with that. First, we initialize the data store by initializing a reference to the data store, which you can see here as I'm calling the cache store. I'll do that in a second. And then all the way down here, we see the prescription data store find, again, pretty much the code as I can find it on the dev center. So prescription data, I want it to be available offline on the client, right? I know it's already sped up through the server-side cache from the EHR, but I also want it available offline. And I want to be automatically updated with fresh content whenever available. So all Kinvey SDKs come with a built-in client-side offline caching layer. I've enabled that here, right? So this is a great feature, right? No more worrying about building your own SQLite, Realm integration. All Kinvey models are automatically available offline, automatically synced with the backend when needed, with just this single line of code to initialize your data store. Okay, well, let's give it a try. Let's put it all together. There comes my app. Yeah, I'm going to log in. Barbara. Log in. As you can see, I have a number of integrations as a demo, including Apple Health data from a local device, and appointments, deductibles, but we're interested here in the clinical summary. So go to clinical summary, and there you go, right? So here we are getting these prescriptions through our prescription data store from Kinvey and eventually also from Redux. We can even double check that, go to the Redux console, all the way back to Redux. I'm going to refresh my screen here. 11:43 where I am, and sure enough, about a few minutes ago, I did the 2 clinical summary objects to get the prescriptions and immunizations, and about 5 minutes ago, I did my testing through the API console, right? So it's that simple. With just a few lines of code, I was able to connect to my backend, log in, get data, which the backend maps all the way back to Redux, and then eventually to EHR. And just really quick to show you on how this would apply to any other language, we also have a provider application. Quickly show you, and I've built it in Angular. So not Swift, but Angular. I'll show you how similar it is. Right, here's my Angular controller. I just drop in the Angular SDK. Look at the login code. I'm logging in with Mobile Identity Connect actually, so we'll show you that in a second. And in terms of clinical summary, same thing here. Very parity across the SDKs. The patterns are all the same. I initialize my data store. Here I use the network store. It's a web app. I don't need client-side caching. And I can do my find by ID with the MLN. And once this callback fires, I get the patient object that I can simply directly put back into the Angular scope for patient demographics, prescriptions, and immunizations. Just to show you what that looks like. Here's my application. You log in. This actually showcases a integration with Salesforce. So this actually logs in through our Mobile Identity Connect through Salesforce. Look at all the patients. Here's Barbara. Let's look at Barbara. And again, here's her clinical summary, right? DOB, SSN, prescriptions, immunizations, and allergies. And again, if you go this back here to Redux, we can see that those queries, in this case just one for the clinical summary object, was made all the way back to Redux. So that's really it, right? In about 30 minutes, I showed you how to create a great mobile experience that is really too easy to develop. Nico, he walked you through exposing your EHR through Redux. I used our reference connector to interface Kinvey to Redux, and then I used just our dev sample code to add a couple of lines of code into my mobile app. And that way I enabled my mobile application to eventually get the prescription data all the way back from the EHR. Okay, that concludes the demo. So Victoria, I think we can move over to Q&A.
Yeah, I think we have time for a couple questions before we have to end. So our first question I think is going to go more towards Nico. It's how do you avoid duplicate data and out-of-date data in the patient updates?
Yeah, that's a great question. So we receive patient updates as triggered from the EHR, and we send them in the order that we get them. So any updates that we receive, any updates we receive subsequently can essentially replace the ones that were there earlier. So if we get a new update and there's a new email address, you can assume that the most recent one is the correct one. As far as duplicate patients, we're using the patient identifier that the EHR sends along, so we shouldn't receive any duplicate patients. If patients are merged, if by mistake in the EHR duplicate patients were created and then merged together, we would receive that as a patient update as well, notifying us that the patient IDs have been merged and the other patient doesn't exist anymore. That's a great question though. Thanks.
Thanks for that. I think this can go for both of you actually, both Ivo and Nico. How do you deal with throttling, which is limiting pull requests so the app doesn't accidentally overuse pull requests on the EHR?
Okay, maybe I'll go quickly from a generic Kinvey standpoint, and Nico can talk to Redux. So our Kinvey Cloud Service has rate limiting in place on a per tenant basis according to the SLAs. So when a mobile app makes too much access to our Kinvey Cloud Service, regardless of integration, that doesn't really matter if it's an EHR, Redux, or anything else, we will appropriately throttle this.
Yeah, and from the EHR side, it depends a little bit on the EHR and what APIs we're mapping into. Certain EHRs will have this functionality in place where they'll say, you can only do this many queries per second or whatever the throttling is. We also have the ability to set up throttling within Redux itself, and primarily this is, we use this as a precautionary measure. There's a lot of data that we would expect to receive from a big health system, for instance, multiple messages or hundreds of messages a minute potentially. And if message volume decreases or stops for any given amount of time, we'll use the throttling mechanism to actually throw an error to start investigating why different messages may have occurred. We can use that same mechanism to throttle pull requests as well. So there's a couple different safeguards in there, either at the Redux level or at the health system and their API. This is typically something during an implementation process that we work through to determine what the best solution is for it.
Gotcha, thanks. And our next question, I think, would also lean more towards Nico, which is, do you have a list of EHRs supported? The question asker says that theirs is obscure.
Yeah, so we don't have a full list of EHRs that we're currently in production with today. Generally, we are EHR agnostic, so any EHR that is meaningful use certified, so used in the outpatient or hospital setting, we should be able to hook into. There really hasn't been an EHR yet that we've ran into, that's used in production that we haven't been able to integrate with. So there might be specialty EHRs or things that aren't covered under meaningful use that maybe a little obscure, but that's definitely something that we'd like to have a discussion about. So if you want to reach out and let us know what EHR you're looking at, we can definitely let you know, number one, if we're using them in production, and number two, we can do a little digging and make sure that that EHR has the right infrastructure in place for us to integrate with it.
And our next question is for Ivo. The question is, obviously this is dealing with highly sensitive PII, so how would you suggest a healthcare app developer secure access to the Redux Kinvey API in addition to standard HTTPS and user authentication, in particular keeping the API key secret to the client hardened?
Right, so the API key that you saw earlier, me putting in, is not an API key that is necessarily a secret, right? It's really meant to just allow the mobile application to figure out what its application in the Kinvey cloud is. The real authentication happens when the user authenticates, and we have a wide range of options, right? So what you saw me do in the patient application was pretty simple. I just do a username password. However, what you saw me do in the provider application is I use the feature of a platform called Mobile Identity Connect. What that will do is we will reroute the authentication request that the user makes to a third-party auth system. It could be Salesforce in my demo, it could be Google, it could be Facebook if you're writing an application that likes to integrate with that. But anyway, all these providers, identity providers, have very secure ways of logging in. They can implement two-factor authentication, they can implement hardware keys, all that kind of stuff. So this all goes through the OAuth 2 protocol or SAML protocol. So we support those. And so by linking to those identity providers, we can provide a very secure path for logging in and authentication.
Thanks, Ivo. And our next question goes back to Nico, which is, how do you deal with historical records, data that was produced before go live? Is there a secondary process of getting a large data dump?
Yeah, that's a great question. So we've worked with a number of groups who need historical data and then obviously need to keep that data updated going forward. So a lot of our APIs out of the box are great for that real-time transactional information. So you want to make sure that you keep a patient record up to date. So you can subscribe to different feeds for that. But that historical data load is something that comes up quite frequently. So we have a couple different methods of obtaining that. The first one is we have some groups who will move into production and we'll start querying the patient population to load the historical records. So we can pull out the clinical summaries for any patient, which has a historical view into what's in that patient's record. And so we would let that run for, through the entire patient population to load the, load your database with the historic information. There's other applications based on the workflow where maybe you just need to know all the patients for the given month upcoming because, maybe it's used within when a patient comes in for a visit or information like that. So we've done certain implementations where we'll turn on Redox in production and wait a month while we're loading in that real-time data that you can save off, and then you go with end user go live, at the end of that month, and you have the backload of the prior month's data. So there's a couple methods that we deploy for that. The main thing that we're trying to avoid here is asking the IT team to basically do an extract. What we found is when you ask IT to do an extract and essentially write a report to pull out the specific information, that can add months to an implementation, as well as add complexity, because it's a whole other team that needs to be involved from the health system's point of view to get that data out. We want to limit the amount of involvement from IT so you can move quickly on the project. And so there's other mechanisms that we use to do that, and not have to ask for more and more resources from the IT organization.
Thanks very much. I think our next question is also for you, Nico, and it is, many EHR installations choose not to use LOINC for labs. How do you deal with normalizing all the localized lab test labels that are not LOINC codes?
Yeah, great question. So we do normalization of the syntax, but we don't do clinical normalization. So this is translating SNOMED and LOINC and ICD-9s and 10s. We're really just taking the coding methodology used within the clinical codes used at the health system level and passing those along. So if they're using LOINC, we'll pass those. If they're using SNOMED, we'll pass those along. If they're on the billing side, if there was that time when they were using ICD-9 and then switched to 10 and then they were double coding. We're simply passing along all the codes that are associated with the record and not trying to build a crosswalk between different code sets.
Well, thanks very much. I think that's all the time we have today. So thanks to both of you for presenting, and thanks to everyone for attending. We'll get that recording out to you as soon as we can. So have a good day, and thanks for coming.
Thanks, guys.
Thank you.